Okay, hello everybody. Well, what I'm trying to do is to explain how you might use the trigonometric formulas that we're learning this year. Now, the three formulas are sine is equal to the opposite divided by the hypotenuse, so we usually abbreviate that to SO. Now, the next formula is cos is equal to the adjacent side divided by the hypotenuse, which we abbreviate to car, and tan is equal to the opposite divided by the adjacent, which we can abbreviate to TOA. So if you can remember the three together, you get SO, car, TOA. So it's easy to remember. Now, which side on the triangle is which? Now, you should remember from Pythagoras' theorem that the longer side, the side opposite the right angle, is the hypotenuse. Now, you can recognise it for two reasons. First of all, it's the longer side, and second, it's opposite the hypotenuse. Now, the reference angle here, this is the reference angle, usually we call it theta, straight across from theta is the opposite side. And you can remember that because opposite the reference angle is the opposite side. Now, adjacent to or next to the reference angle is the adjacent side. So, if you have to remember them, O is for opposite, A is for adjacent, and H is for hypotenuse. Okay, so O is for opposite, A is for adjacent, H is for hypotenuse. Now, if we rotate the triangle around, we still end up with the sides in some kind of orientation so we can work them out. Now, right opposite the right angle is the hypotenuse. Straight across from the reference angle is the opposite side, and right next to the reference angle is the adjacent side. Okay, in this triangle down here, let's see, straight across from the right angle is the hypotenuse. Opposite the reference angle, well, is the opposite side, and right next to the reference angle is the adjacent side. So, how can we use this in a problem? Well, let's take a look. Okay, what we want to do is to find the unknown length, x. We want to know how long it is from here down to here in a triangle where this side length is 17 and our reference angle here is 51. So if it were me, I'd label each of the sides. Now, straight opposite the reference angle is the opposite side. Right next to the reference angle is the adjacent side, and opposite the right angle is the hypotenuse. So we have the hypotenuse, and we know the length of the hypotenuse, and we want to know the length of the opposite side. So which formula should we use? Well, which formula involves the use of the opposite side and the hypotenuse? Well, if you look back through your formulas, it's the sine formula. Now let's plug in what we know here. Well, we know the reference angle is 51. So sine of 51 is equal to, now the opposite side is unknown, we'll call that x, and the hypotenuse, we'll call that 17. Now, we need to get rid of this x divided by 17. Now, the opposite of dividing something by 17 is timesing something by 17. So if we time something by 17 on both sides, we keep the equation balanced, and dividing by 17 and timesing by something by 17, they cancel each other out. So that just leaves x, and we'll end up with 17 times sine of 51. Now, if you put that into your calculator, you should find it equal to 13.211. Now, we can approximate that to two decimal places if you like. It's closest to 13.21. Alright, let's try another one. Okay, now, here we have to find an unknown length y in our triangle below. Well, here's our reference angle. Now, straight opposite our reference angle is our opposite side. Right next to our reference angle is our adjacent side. And here, opposite our right angle, is the hypotenuse. So, we know the length of the hypotenuse. We want to know the length of the adjacent side. Well, which trigonometric formula involves the adjacent side and the hypotenuse? Only one, and it's the cos formula. So let's put on all the things we know into the cos formula. So cos of the reference angle is 38. The adjacent side here is y, and the hypotenuse is 12. Now, let's see. Well, we need to get y on its own, so we'll need to undo this y divided by 12. The opposite of dividing something by 12 is multiplying it by 12. So if we multiply by 12 on both sides, we keep the equation balanced. Now, dividing by 12, timesing by 12, they're opposites and will cancel out. So that'll just leave y on its own. Now, on the other side, we have y equals 12 equals 12 times cos 38 degrees. Now if you plug that into your calculator, you might get something like 9.45612. Now usually we'll abbreviate to 2 decimal places. Now this funny looking sign here is an approximately, and I could say this was approximately equal to 9.46 rounded to 2 decimal places. One more. Okay. Now let's see here. Here's our reference angle. Here's our reference angle here. So theta will be 58. Now straight opposite the reference angle is the opposite side. The opposite side is straight across from the reference angle. Now, opposite the right angle is the hypotenuse, and right next to the reference angle is the adjacent side. Okay, so let's see. Now we want to know the length of the opposite side, and we know the length of the adjacent side. So what trigonometric formula involves the opposite side and the adjacent side? Only one. Tan of theta is equal to the opposite side divided by the adjacent. So in place of the reference angle goes 54. In place of the opposite side goes z, and in place of the adjacent is 19. Now how do I undo this 19 so I can get z on its own so I know what it's equal to? Well, if I multiply by 19 on both sides, divided by 19 times by 19, they'll cancel each other out, and that'll leave z on its own. Now if I have 19 times by tan of 54, I can plug that right into my graphic calculator and say 19 times tan of 54 will be equal to 26.151256. Now all these numbers I don't really need. Usually I'll round to 2 decimal places. So I'll say it's about 26.15. Now, don't forget your units. So if I were to put here, this was all in centimetres, I should put centimetres down here. Alrighty everybody, well I hope that helped, and I'll see you in class.